Two different customers receive the exact promotional email for a new shoe. One taps the notification instantly. The other swipes it away without reading. The shoe in both emails is identical, but while the product hasn't changed, the words used to describe it have been shifted to target two different sets of motivations. This presents a strict engineering challenge. You have a single product brief and one AI system, but you need to scale that level of precise targeting to 5 completely different audiences. A basic zero-shot prompt feeds the brief to the LLM, asking for 5 variations in one step. That breaks down fast. A production-grade architecture requires a multi-layered pipeline, routing requests through intermediate layers for context, constraints, and caching before generating a single word. Enterprise AI personalization works when the system internalizes a user's psychological profile and generates targeted copy without the end user ever realizing they've been placed into a segmented bucket. The first layer of this pipeline defines the target personas. The system does not sort users by age or zip code. It maps them strictly by psychological motivations. Take a group we'll call sneaker mavens. These are the enthusiasts waiting in physical lines for limited releases. In the back-end code, their profile contains a precise psychological trigger. Their identity starts with their feet. They shop for status. Because they are driven by status, the system injects a specific vocabulary guide into the prompt. The AI receives instructions to lean heavily on language implying urgency and exclusivity, phrases like secure your status and be the first to own. Compare that to the active athlete persona. Their primary motivation is strictly functional. The back-end profile explicitly defines this. They shop for stats. The AI shifts its output to feature performance metrics like cushioning, traction, and ankle support. A third group, the fashion-forward expressionist, views footwear differently. The sneakers are just one piece of a larger aesthetic puzzle. They care about styling options, not performance or release dates. Not every customer fits into an enthusiast category. The system also includes instructions for a neutral audience that prioritizes practicality and comfort over hype. The prompt for this segment includes a critical note. It tells the AI to dial back the trendy language and adopt a clear, mature tone. Robust audience segmentation relies on explicitly mapping these distinct psychological motivations at the code level, entirely independent of the product itself, before any text is generated. Giving the AI these detailed personas introduces a major risk to the user experience. A standard LLM will often try to greet the user by their internal database label. To prevent this, the architecture uses a constraint called implicit adaptation. In the copy generation prompt, there is a hard constraint. The response must naturally suit the audience without explicitly naming them in the output. If the prompt lacks this rule, you get outputs like this. For our active athletes out there, it exposes the sorting mechanism directly to the customer. With the rule applied, the output integrates performance-based vocabulary organically. The labels disappear entirely. When a customer identifies the message as the result of algorithmic binning, the personalization loses its impact. Seeing internal database labels makes the copy feel robotic and data-driven. The AI absorbs the vocabulary guides and matches the tone, while keeping the structural parameters invisible. The system reinforces this with strict instructions forbidding any introductory phrases, markdown notes, or meta-explanations in the final text. Personalization works when the AI treats your vocabulary guides as invisible guardrails. It shapes the tone without breaking the fourth wall. When you ask a single AI model to write 5 parallel variations from the exact same product brief, a new issue emerges. The model will reuse identical creative verbs across the different audiences. To fix this, the pipeline expands, adding cross-audience memory and a feedback loop. This utilizes a technique called cache injection. As the AI generates copy for one audience, those results are fed back into the next prompt as negative constraints. The prompt reserves a block for previous generations, injecting cached responses into the instructions. Product names can repeat, but reusing descriptive language is strictly forbidden. These cached entries are formatted into structured markdown blocks. This allows the model to efficiently scan the text and avoid pulling from the same pool of creative language. Further instructions enforce structural variance and tense consistency, ensuring the outputs don't suffer from jarring tone shifts or feel like minor rephrasings of the same idea. LLMs are probabilistic, meaning a few repeated words can still slip through. The pipeline accounts for this by adding a final validation node,
a secondary fix agent. This agent runs post-generation. Its sole purpose is to read the outputs, catch duplicated or obscure terminology, and replace it before the text reaches the end user. Scaling an AI operation requires this two-layer approach. You prevent errors during generation with cache injection, and you actively correct them afterward with a dedicated validation agent. That is the complete architecture of a production-grade prompt pipeline. It replaces a simple zero-shot request with a rigid sequence, define psychological motivations, enforce implicit adaptation, and validate outputs using cross-audience caching. Injecting specialized vocabulary drives the initial conversion, but it's the system's ability to hide its own machinery that preserves customer trust. Controlling tone and variance only solves part of the equation. There is still a critical technical hurdle remaining: factual accuracy. A system that flawlessly targets a user's psychology is useless if it starts inventing fake product features. Keeping the LLM anchored to reality requires an entirely different set of constraints. That is where hallucination prevention comes in.